Hey guys, welcome to Chapter 5. So Chapter 5 is going to kick off our Earth Science unit. So it is going to be about space and planets and the sun and all of that. Okay, so our first chapter is called Exploring Space. So the concepts that we're going to look at today will be how do scientists use the EM spectrum to study the universe? So we are going to be using the Reading Essential like normal, but then we're going to be using the science notebooks. It's a little bit different than the outline notes, okay? I think you guys are ready for this. So observing the night sky. If you look up at the sky on a clear night, you might be able to see the moon, planets, and stars. These objects have not changed much since people first began looking at the night sky. People in the past spent a lot of time observing the sky. They told stories about the stars, and they used stars to tell time. Most people thought Earth was the center of the universe. Today, astronomers know that the Earth is part of a system of 8 planets revolving around the sun. The sun and the planets are part of a larger system called the Milky Way galaxy. All right, so we're going ahead and highlight that. So the Earth is part of a system of 8 planets revolving around the sun, and that is a galaxy, the Milky Way galaxy. The Milky Way contains billions of other stars. It is one of billions of other galaxies in the universe. Even though Earth might seem small in the universe, it could be unique. Scientists have not found life anywhere else. One advantage astronomers have over people in the past is the telescope. Astronomers use telescopes to observe many more stars than they could with their eyes alone. So we'll go ahead and highlight that. Telescopes gather and focus light from objects in space. Astronomers use many kinds of telescopes to study the Earth, the energy emitted by stars, and other objects in the space. Okay, so telescopes is going to be something that we're going to spend a few days looking at, whether it be you're in person or whether it be a virtual, okay? All right, so let's stop there and go over to our science notebook. So observing the night sky is what we just read. Okay, that section is what we just read. So Earth, okay, so one of 8 what? It's one of 8 planets revolving around the sun. And that comes to the sun. The sun is one of billions of stars in the Milky Way galaxy. And that comes to Milky Way, one of billions of galaxies in the universe. Okay. All right, so you see the next section that we're going to look at is EM waves, all right? So let's go on back to here. So we see that we are on EM waves, all right? So this is going to be a blast from the past from our last physics unit, right? Stars emit energy that radiates into space as electromagnetic waves. All right, so let's go ahead and highlight that. Stars emit energy that radiate into space as EM waves. Electromagnetic waves are different from mechanical waves such as sound waves. Sound waves can travel energy through solid liquid gases. EM waves can travel energy through matter or through a vacuum such as space. The energy that they carry is called radiant energy. All right, so let's just remind ourselves that they can transfer energy through matter, which is our solid liquid gas, as well as through the vacuum, okay? All right, so I see a vocab word, so I'm going to stop and highlight that. Electromagnetic spectrum is the entire range of radiant energy carried by electromagnetic waves. As shown below, waves of the EM spectrum are continuous. All right, so we have a range here, right? We have talked about EM the EM spectrum in December, right? Last chapter. So I'm going to switch out here. I don't have vocab anymore. All righty. Gamma waves have the shortest wavelength, and they're at one end of the spectrum. Radio waves have the longest wavelengths and are at the other end. This is super cool, I think, this whole idea of radio waves. Radio waves can be thousands of kilometers long. Gamma waves can be smaller in length than the size of an atom. That's pretty cool. Okay, so here we have our wavelength. Okay, we're pretty comfortable with this, understanding that they are based on wavelength, and they go from this particular graph has it set up from the shortest wavelength, and that's going to be high frequency, all the way down here to the longest wavelength, and that's going to be low frequency. Okay, so radio, micro, infrared, visible light, UV waves, X-ray, and gamma rays. Okay, so then we have a little picture with what their uses are. All right, so you can take a look at that. Okay, so we're going to just finish this page today, and then we'll go into our notebook and see what we can fill out, all right? Okay, so invisible waves. Humans see only a small part of the electromagnetic spectrum, the visible part in the middle. All right, so let's go ahead and highlight that. Visible light includes all the colors you see. All right, so this is a reminder of what we learned about last chapter. You cannot see the other parts of the electromagnetic spectrum, but you can use them. When you talk on a cellular phone, you use microwaves. When you change the TV channel with a remote control device, you use infrared waves. Okay, radiant energy and stars. Most stars emit or produce energy in all wavelengths, but how much of each wavelength they emit depends on their temperature. All right, so let's go ahead and change our color and let's highlight that. How much of that wavelength they emit depends on their temperatures. Hot stars emit mostly short wavelengths, such as X-ray, gamma, and ultraviolet. These waves have higher energy. Cool, so let's go ahead and change that. Cool stars emit longer waves with lower energy, such as infrared and radio. Now the sun has a medium temperature range. It emits much of its energy as visible light. Why you see planets and moons? Planets and moons are much cooler than even the coolest stars. They do not make their own energy, so they do not emit light. You can see the moon and the planets because they reflect light from the sun. All right, so let's go ahead and highlight that we have do not make their own energy, so they do not emit light. Okay, so planets and moons. You can see them because they reflect light from the sun. Okay, similar to any type of object, a book or a desk. You can't see that unless there is a light source, and so we see those, the moon and the planets, because the light from the sun is reflected off of them. All right, so light from the past. All EM waves from radio to gamma rays travel through space at a constant speed of 300,000 kilometers per second. All right, so let's go ahead and highlight that. This is called the speed of light. The speed of light might seem incredibly fast, but the universe is very large. Even moving at the speed of light, it can take millions or billions of years for some light waves to reach Earth because of the long distance in space. That's crazy, isn't it? It takes time for light to travel. So you see planets and stars as they were when their light started its journey to Earth. It takes very little time for light to travel within the solar system. Reflected light from the moon reaches Earth in about 1 second. Light from the sun reaches Earth in about 8 minutes. Light from the sun reaches Jupiter in about 40 minutes. Okay, so let's go ahead and highlight a little bit of that. Okay. All right, the moon about 1 second, and then the sun to reach Earth 8 minutes, and light to reach Jupiter 40 minutes. Light from stars is much older. Some stars are so far away that it can take millions or billions of years for the radiant energy to reach Earth. Therefore, by studying energy from stars, astronomers can learn what the universe was like millions or billions of years ago. So we're going to go ahead and just simply circle that, okay? All right, so that finishes up the reading of the text today. So let's go into our science notebook, all right? So with this graph, what we have is just you really are looking at the type of wavelength, energy, and temperature of the stars. Okay, so the wavelength of gamma has the shortest wavelength, has the highest energy, and so it's going to be the hottest star. Okay, X-ray. So wavelength for gamma is shortest, so X-ray is going to be short. And then let's just go ahead and fill these in. The wavelength is getting longer, isn't it? And so it has long here and longest down here. Okay. All right, because the spectrum is arranged by wavelength, and so with the gamma we have the shortest wavelength, and the radio we have the longest wavelength. All right, so if the energy of gamma is highest, then X-ray is going to be high, and this is going to be medium. This is going to be low, and the radio is going to be lowest. Okay, so if the temperature of the gamma star is hottest, the hottest that's giving off predominantly gamma rays is going to be hottest. Hot for X-ray, medium for our sun, cool for infrared, and coolest. Okay, so I want us to write in here that this right here, this is our sun. Our sun gives off predominantly visible light, okay? Thanks. That is what we need, right? So that is a good thing. All right, so I want to, off to the side here, I want us to write a little bit of these times. Okay, so the light from the moon to the earth takes 1 second. From the sun to the earth, what do you remember that was? 8 minutes. And from the sun to Jupiter, remember that? That was 40 minutes. Okay. So describe what scientists learn about stars using the electromagnetic spectrum. Okay, so scientists learn about the star's age, its temperature ranges, because remember, they are going to analyze the type of wave that's being emitted and then therefore can correlate that to a particular wave on the EM spectrum. The temperature of the temperature range, and then distance from Earth. Okay, that's the last thing we are covering today. I do want us to write the speed of light And that is going to be for all of our waves. They all travel at 300,000 kilometers per second. So all of the waves travel that quickly, okay? All right, so make sure that you have this filled out for this very first part of our lesson. Next time, we're going to be doing with the telescopes, talking about the telescopes, okay? All right, have a really good day. Reach out if you need anything. Bye-bye now.